Connect contracts are, as their name suggests, connection contracts between an external data provider, such as a database or data repository, and Project Hadron's implementation canonical. The brokerage process is independent from the component task itself, loosely coupling the external data from the code's expected implementation canonical. This results in true separation of concerns. So before we get into the implementation, a quick look at how this works practically. So what I've set here is created in the first instance, an instance of the transitioning component. And what I've also set up is 3 different handlers. Now these connection contract handlers and connection contract are the contracts that identify how your connector is going to work. So here we've got a Python source. Here we've also then got a pandas source. You can see it's a pandas handler using the pandas source handler. And then finally an AWS one, which is giving a URI that points to and identifies the fact that it is an S3 bucket. And then again, the module name that we're using and the handler that we're, in this instance, a source handler. So running through this, we create the instance. Just set up these connect contracts, and then we simply pass these connect contracts. In the first instance, we're going to pass through the Python source. From here, we can then load. Notice no parameters, so it has no concept of this handler. That's the true separation of concerns. We can now load whatever that's pointing to, and you can see also when we run this and look at the connector report, you can see that we've now got a primary source connector that is pointing to the Python handler and Python source handler. Now we can very, very easily change this. So again, now we're going to take the pandas source. We just simply change the source contract. And as you can see, we load the data up again, but this time using pandas source. And when we look at the connect contract, you can see that this is now changed to be a pandas handler. And we can obviously then connect to things like AWS. So taking the AWS source, putting that in place. And again, when we look at the connect contract, you can see that we're now pointing at a data source that is sitting on AWS and using the AWS handlers. Now, this is particularly powerful because this is completely independent of the component itself. So I can now change this instance to be a feature catalog instance, and I run the feature catalog instance, and you'll see that I'm just going to use the same pandas source handler to pass it through. And sure enough, the feature catalog now loads that data in the same way we did with the transitioning instance. The way this works is through polymorphic behavior and abstraction. So in the first instance, we have our interface that brokers between the connecting implementation and canonical. So here you can see we have the abstract source handler and the abstract persist handler. The reason we have a source handler and a persist handler is it ensures that we can connect to existing sources without the worry that we might overwrite them. So normally what you do is source handlers are dealt with by the source handler abstraction, and where we're retrieving and saving data and we want control of it, we're doing it through the persisted handler. So the way this works is based around a connect contract. The connect contract is set up providing a URI, module name, a handler, a version number, and any other keyword arguments that one wants to pass through to the abstracted handler. The property manager stores this connect contract until such times it's ready to be used. When the component instance asks for a connector name that the property manager has stored, it retrieves that connect contract and then passes it to a factory handler that creates an instance of the particular handler that has been requested. And here we have the implementation as code. So this is the interface that the canonical expects. And if we go to the discovery connectors, you can have a look at how some of these have been implemented. And it is very straightforward, and you can certainly use these as a template. So what we can do is look at the simplest one, which is the Python handler. So you can see with load canonical, what we're doing is we are retrieving our connect contract that's associated with this instance. And then we are looking at the potential file type that we're either inferring from this line here, or that we are taking directly out of the parameters. We're also popping out any read parameters that we have, and then we're passing those through to our various methods that we've got to either load pickle, load CSV, or load JSON. And likewise with the Python persist handler, you can see that we inherit the Python source handler and also we inherit the abstract persist handler. Pandas does it in exactly the same way, almost identical, except there's more options in terms of how Pandas is extracting that information out. And then with AWS, at the top, you can see that when we instantiate this, we're setting up the connector to the S3 bucket. And then when we are loading the data, we are then using that connector and again taking out the different sets of parameters, and this time we've got several different parameters. We've got the file type, we've also got an encoding, and we've then got S3 get parameters as well as the read parameters. So that's it. Please have a play, and hopefully you should be able to write your own connectors exceptionally quickly and try them out.